Okay, so some of the background into why I chose the study I did. The research for occupational health has changed a lot over the years, especially over the past 3+ decades. Back in the 90s, the research was much more focused on chemical exposures, asbestos, lead, cancer. Now in the 2020s and the 2010s, we are seeing a shift much more toward the psychosocial aspect of things, as well as things such as stress, productivity, work-life balance. So I thought I would throw out some definitions to understand what the title is even saying for this thing. So what is the text mining applied bibliometric study? The bibliometric part analyzes a bunch of the patterns in the research that they had compiled, and the text mining portion just means that they use a software analysis to gather huge amounts of data to come to their conclusions that they had. So they had over 48,000 article titles that they searched through over those 3+ decades from 26 different occupational health journals that they use. So it's a huge database they're collecting from. Why do we care about this study at all in the first place? So, like I said, nowadays the focus is much more on psychosocial risks, and these are becoming more noticed as real world issues. As more people work remotely, we have aging workforce, and we have more and more burnout. Occupational health and the research has always been changing and continue to change, so we need to be tracking that. And as far as I'm aware, this is the best study, I'm sure I'll be proven wrong at some point, that I could find that tracked as many articles as it did to see what the topics were for occupational health and how those trends changed over the decades. And as we get newer and newer industries and more industries, we'll see those topics of research in occupational health continue to change, and that will help policymakers and funding decide where to allocate the money and time and the effort into these types of things. This slide is just reiterating that it's been changing a lot over the past 3 decades. Okay, so the why behind this one. Again, there's been a lot of societal changes and global developments, and it also tells us what the emergent issues are with occupational health and what issues are not being studied as frequently now as they were in the past. So it's kind of interesting just to see what trends are fading away and what is continuing to exist as we move forward. What's interesting to note about this one is that they were just looking at the titles of the studies. So they weren't looking at the studies themselves as a whole. That was too much information to go for at once. So they were just tracking the titles. They were categorizing them and comparing them. So again, there's 48,000 articles, and we'll show later how they ended up at that number because they did start out with even more. The titles contain 714,000 words. At the beginning of the period of collection, so the early 90s studies, those studies on average only had about 7 words in their titles, and for 2022, they had closer to 14 words in their titles. And we'll see later why that becomes relevant, because that changes the way that they were categorized. And again, it's a very long period of data collection. Here's a flow chart that they have in the study as well that I wanted to point out. So you can see at the top, they started out with hundreds of different journals, and then they slowly began to narrow it down, and they ended up with the 26 PubMed journals that we referenced at the beginning. At the bottom, you can see here, they narrowed it down all the way down to 48,645 articles. On the right here, you can see that they eliminated articles that were before 1990 and in 2023, a little over 6,000. That was because they wanted to have at least 5,000 words per year in for the research titles in order to get a better sample. So they categorize these into 4 different categories, 17 subcategories, and came up with categories in its years published. They used the statistical analysis of Cage Coder 3.0. I don't know if any of you have heard of that. I've heard of that before. And then it sounded like they used some R after the fact. These were broad category topics in order to narrow down the amount of categories that they have, so they didn't just have thousands of different categories. So some of the topics that they did find that were increasing in frequency over the time period were the growth on the stress, shift work, work-life balance, and self-behaviors, as well as aging workforce, remote work, and mental health. There was a lot more emphasis on safety, and if you think about it, to be fair, like a lot of companies, all companies, they have to make money and be productive. So that's why a lot of research has been put into keeping workers injury-free and healthy, so they don't have to waste money on either rehabbing their worker population or just having them take up much time. Research has been focusing more on productivity in the more recent decades for being cost-effective. And from a global perspective, most of these studies were in higher income. So that was worthy of noting, just because we do have less of a data bank of information for lower income countries. So going forward, one of the goals or the hopes ideally is to get more of the lower income countries more research on health and safety topics. So this is a heat map of topics that have changed over the decades. So if you look over here on the left, in the early 90s, you can see there was a much bigger focus on things like chemical factors and organ damage and disease. And as you shift to the right more towards 2022, you can see there is a much bigger focus on psychosocial factors. And if you look right at the end there, the last 3 years on this chart, you can see the biological factors are increasing as well, which I thought was interesting because you see a huge uptick in biological research post-COVID. So some of the topics that were declining that they found were the chemical exposures, mostly asbestos, lead, dust, and the main chemical exposures that you're going to be hearing about in the workplace. There was fewer focus on disease, such as cancer, lung disease, and similar diagnoses, which does not necessarily mean we solved all of these problems, right? It just means that the focus has changed from less research on these topics to the psychosocial aspect. The decline on the research for respiratory, cardiovascular, and other organ damage, again, is an indication just that the priorities have changed, not that we've completely solved all the problems. Now, here are some things that I just picked up when I was reading it that I thought were pretty interesting, and just the practicality, right, of companies being able to survive day-to-day business, and there's stakeholder, shareholder, investor pressure to keep business going. So that is one of the main reasons why we see such a huge focus nowadays, things like that. The COVID influence, the biological factors. And then I could have been misinterpreting this, but the way I understood it when they mentioned 9/11 in the article was because that was one of the main reasons why we study firefighters nowadays. And if that's the case, I probably should have just added two together to see that. But I thought that was an interesting focus. Again, if I understood that correctly, as to why that's such a huge topic of research. So again, just because we are focusing less research on silica and other chemical exposures does not mean that we have effectively solved the problem. And lung cancer, COPD, heart disease, hypertension, all of these things are still heavily influential in workplace deaths and serious illness. So there, ideally, in the future going forward, we can find some kind of a balance between the two to maintain research between all of these topics. Okay, so this correspondence analysis, just wanted to point out here. So each of the quadrants, it kind of goes in almost a U shape here, starting with the 90s and then going up until the 2020s. But if you look over in the quadrant with the 90s, you can see topics more like hazard and asbestos and things like that. And if you look over into 2020 to 2022, you see things more like relationship, time, employee association, quality training. So it just shows again how the prevalence of these titles, the subjects and the titles, has changed over the time. Conclusions, to reiterate, so the OHS has shifted focus from chemicals to psychosocial factors. We are focusing much more on mental health research, work-life balance, and productivity. We need to somewhat strike a balance between the chemical hazard research as well as the psychosocial aspects going forward, as well as having more research done in low-income countries. And yeah, that's the implication, that we should have strike some kind of a balance with all of that. Some of the strengths of the study: they had a huge data set. It was a comprehensive scope, lots of different topics. This method I thought was pretty cool, with the bibliometrics and the software analysis they used to just collect massive amounts of data from titles. They had pretty clearly identified what was actually happening with the changes of the trends of this research. And it's very relevant to policymakers and funding to determine where we should look at putting our funding in the future. Some weaknesses of the study I noticed: it was just, it was just the titles. It didn't have the entire text of all of the studies. So you're not getting the full picture of what any of the impact of any one of the articles would have been. Other OHS research should have been left out, since it was just the 26 PubMed journals. It was pretty subjective how they came to the conclusion of what the titles were. So if you would have got another group together, they might have decided on categorizing or naming the titles slightly differently. And again, there was this time trend bias. So towards the beginning in the early 90s, this time period, they were, I want to say it was about 7 words per title, and then for 2022 it's about 14 words per title, which just means that towards the end of that period, you're going to have a disproportionate amount of those words in those titles represented. So it might be overrepresented towards the end. And then, from my understanding, the bibliometrics are still evolving as we get stronger and stronger technology. I asked ChatGPT what it thought some of the weaknesses of the study were, and I thought it actually had some really good points. So it just said that the titles show what topics shifted, but not necessarily why. Like I was saying, we still have a huge problem with chemical exposures, but we are not putting as much focus into them, and the study wasn't able to tell us why. Again, it was the developed country bias. It was English language bias, which I thought was interesting, because I wonder what else other data we could glean from other languages in other countries. Category overlap, so all the subcategories could reduce decision, and it's only quantitative, so it doesn't show the actual impact of any one study. It just shows the sheer amount and volume of each category. And that's all I had. Thank you. We can go to discussion now. Yeah.
Slight deviation, but kind of along the same lines of what you were talking about like declining trends and stuff. But in like in table 1, where it's like talking about the number of articles published per year, it seems like there was like a pretty big jump from like the 2000s to the 2010s. Was there like some sort of change in occupational health that occurred during that time frame?
Like the topic shifting from 2000s to
the quantity.
The quantity from 2000 to 2010.
Yeah, there seems to be a lot more research in occupational health after 2009.
That is a great question. Actually, I'm not sure. I did not catch the reason behind why, but that is a good observation. Yeah.
You got one over here.
Oh, yep.
Yeah. So they clearly focused on occupational medicine. And I noticed one of the trends was the increase in mental health related research. And this is not just for you, this is for everybody. Why do you think there's been this shift over time over the last 32 years, plus, towards more research in that domain? What do you guys think? Yeah.
Is it just more acceptable to talk about? Cause I know that like back in the day, it was kind of less
Mhm.
something people wanted to bring up and mention. It was all
Yeah.
going to be like, okay, but nowadays people seem to be more open.
Yeah, I mean, there's a cultural change and shift that's happened over the last 32 years, right? Just try to have a conversation with your grandparents about mental health, and then try to have a conversation with your parents about it, and then try to have a conversation with your peers about it. You're gonna have very different experiences, right? If grandma and grandpa will talk to you about it at all, something about bootstraps will come up, and lifting yourself up and just, rub some dirt on it, you can do it, right? So it's just very different perspectives. And I think to some degree that's playing out in some of these trends. Like there are cultural shifts that are happening in occupational medicine and in research that are driven maybe not so much because of the change in the prevalence of certain things, but because of a shift in societal and cultural dialogue and acceptance of considering certain factors in life. I don't know, just a thought.
Would you also say it would be a major increase in like depression and other mental disorders over
No.
time?
Based on the research, there actually has not been an increase there's not been an increase in the percentage of the population who have mental health disorders,
Is
right?
it just more diagnoses?
There's more diagnoses because there's more people who are receiving mental health care. So if you just look at, if you look at the number of diagnoses, you look at the number of people who are expressing that they have these things, it's much higher now than it was years ago. However, the actual symptomology and so forth, the percentage of the population who actually have like schizophrenia and things like that, that hasn't changed, right? Now, population has gotten bigger too. So between population and our willingness to talk about it, we're inundated with people who are seeking care in this regard, but the actual prevalence of it has not changed.
Yeah, I think one of the interesting points about that is also our understanding of these diseases has changed. So
Yeah.
like, like people are getting diagnosed for things they wouldn't have necessarily gotten diagnosed for
Yeah.
previously because our understanding of what that mental health problem or illness or whatever is has changed. So we're now like, oh, like this is more of a spectrum rather than just like a straight.
Yep. Our
one
accuracy and
diagnosis.
specificity when it comes to our measurement of all these things has gotten better. Like a spectrum when it comes to, for example, autism and, other things of that nature. Now schizophrenia is not just one thing, it's a lot of things. So, yeah, and so I think this research has led to the ability of practitioners and clinicians to diagnose and help more people because we're realizing that more people have actually been suffering from this that just haven't been able to be diagnosed.
Kind of along those lines, I wonder too how, and I know we don't, in the study, they don't talk about it, but how much what the journals want to publish impacts as well. If
Yeah.
people just got tired of hearing about chemicals and they wanted to hear about something new. But I think it'd be interesting to see, there's no way to do it in this study, but understanding how going away from some of those other topics has potentially endangered those populations in ways that we aren't even talking about anymore because mainstream has moved more towards other interesting or like buzz topics. And I think it'll be even more interesting to see how governmental changes impact, like if they were to do this study in 20 years to see what the change, 2024 and past would look like.
Totally, that's a great point. Now, one other thing I might ask the group is, where do you guys think that things are gonna go with occupational medicine research in, 10, 20 years? What is it gonna look like? And are the trends gonna continue to shift in the same direction, or are you gonna see something totally different? I could see it maybe being something we couldn't even predict, right? With how fast careers are changing and everything.
Can I put a pin on that question? It's a really good question. Can I put a pin on that because it's sort of shifting? Claudia had a question, a comment that she wanted to mention as well online.
Thank you. Thank you, Boba. Hi, Tanner. Thank you so much for your presentation. So could you, regarding like why there might have been a shift, could it be because now that the other topics have been researched and we have some knowledge about them, then we can shift our focus to things that before we were unaware of?
Yeah, I think totally that's, sounds to me that's kind of overlapping with what he was saying, but, it's an interesting point because, yeah, it's like, we'll probably never reach the point, right, where we have sufficiently researched the topic to say that we've been exhaustive with this one topic and we don't need any more information from this thing. But you're right, it's like maybe we did get to the point where funders, researchers, or whoever was deciding this, that we're like, this is enough information for now. And we have all these other new relevant things coming up. So maybe it is time to kind of pivot, shift focus, and just work on some other things for at least a while.
Then I've got a comment, sorry, I've got a comment from Dr. Olson online, and then I'll let you shift back. Dr. Olson says stigma and treatment seeking, receiving remains a problem for mental health. Only 10% of people with substance use disorder will be offered treatment, and less than half of people with mental health challenges will seek treatment. And 30% worry of work consequences for seeking mental health treatment. So context for that.
I just want to point out that the workforce, the type of work have also changed over time. A lot of production work transferred overseas, but your literature is mainly in English language, right? So in certain countries. And then also because of the automation, the type of work, we use a lot of machines to do the work. So the occupational health emphasis, like the questions posed in occupational health is also changing over time.
Definitely. Yeah, I think you covered kind of two topics that overlap there, right? Because you have the shift in research changing, right? And that's because manufacturing jobs might be moving overseas. And when we also know that there's a lot of other countries that don't have research on these chemical exposures as well. So we're just not seeing that, even though the work is still being done in various places.
Specifically regarding chemicals, there might also just be more regulation about them and like knowledge. Cause like, I mean, I know when I was working in a plant with chemicals, we had like safety data sheets everywhere and you were like required to go through a training on like how dangerous the chemicals were and what to do in a spill. So I feel like it's maybe just not as like it, since it's more regulated and controlled, it's like someone else said, not as much of like a buzz topic because it hasn't been like solved, but it's not as necessarily big of an issue as some of the other things, maybe.
I think that's a fair point. Yeah, it's just priority shifting over time. We have a basic foundation of knowledge and what we need to put on SDS sheets for most companies. We're like, okay, well now we shift over to this more social aspect.
Before I interrupted you, you were, I think, getting ready to ask a question about where folks think the research is gonna go. So I thought that was a good topic.
Sure. Yeah. Yeah. What do you guys think? I guess that's kind of a, let's open it a question for everybody. Yeah. Where do you think it might go in the future?
I think we'll see a lot more research on the like effects or impacts of people working alongside, like as AI improves and then generalized robotics improve. I think people will increasingly work alongside and then eventually be replaced by these systems. And I think there'll be a lot of research into like how that affects workers, general population and stuff.
Yeah, totally agree. Totally can see that.
Claudia said online, she said machine-human interaction.
100%. And then maybe even back to more physical safety of avoiding the machines too. So there's less limbs getting chopped off and things like that.
Probably already a current topic, but I feel like we're gonna start hearing a lot more about like microplastics and stuff in the coming years because the more I hear about it, the more I feel like it's a big problem that hasn't been like fully addressed yet.
Oh yeah, yeah, 100%.
I think potentially more privatized research, so research that's not funded by public sources. And then with that, I think it'll be interesting to see how different industries fund research and the morals and ethics behind that, and then what it will do to the evidence that comes out in certain situations. So having less of a public eye around it and having more privatized research.
Yeah, that'd be cool to see for sure.
Anything else for Tanner? All right, we'll call it good.
Yeah.
Working now? All right. Good afternoon, everybody. My name is Hancock. I am also a second year industrial hygiene student here, University of Utah. In the same cohort. Very excited to be presenting today about something that really interests me. And kind of going off of what Tanner mentioned in his presentation, was one of the topics in declining OHS topics was asbestos, lead, and mold. And I really wanted to present today on something that interests me. I work in the field of environmental testing, so I work a lot with mold and asbestos and lead. But I've never sampled lead in soil. So I wanted to learn a little bit more about that, and also educate you guys a little bit more about it too. But it's true, there were few and far between articles that I could find when trying to research something to present on this week. But I did find one that was very interesting related to field portable XRFs, which is a device used to sample lead in soil, in paint, etc. And so that's what this presentation is on today. It's an examination of paired XRF analysis performed in the field and laboratory ICP AES results. It's a big mouthful and a lot of abbreviations in there, but I promise I'll cover everything, make sure everybody understands it. So I wanted to give a quick overview about what lead is. It's an element, obviously in the periodic table, but it's also found commonly in paint, also known as lead-based paint. Paint, dust, soil, and water from lead pipes as well. It's mainly caused by, lead in soil is mainly caused by the deterioration of exterior paint components. And it's also found in leaded gasoline exhaust that has deposited as ultrafine metal allied aerosols and then seeped into the soil and mixed with that. Leaded gasoline was banned in 1996 with the Clean Air Act. And that's why when you go to the gas station today, the main number that you click on is unleaded gas. So it was banned in the 90s. Lead itself can remain in the top layer of soil indefinitely because as an element itself, it's very hard to break down and deteriorate on its own. And it is primarily hazardous to children and their developing bodies, not so much to adults because adults are fully developed. Lead has been linked to behavioral disorders, mental retardation, and CNS impairment when children are exposed at high levels. Kids tend to eat, gnaw on, chew, and lick everything. And that includes windowsills in houses, walls, doors, dust off of the floor, and kids even eat soil. Lead can be found in all of these things. And so since their bodies are developing, it's a big risk factor for children more so than adults. So in the past, there's been a lack of similarity in results between field portable XRF analysis
and laboratory analysis for lead in soil. And so the authors here conducted a paired cross-sectional method validation study, which aimed to prove that XRFs can also produce corresponding one-to-one ratios similar to laboratory analysis. And they used a new protocol that measures lead in soil by grounding, sieving, and analyzing to less than 250 microns in particle size. So samples here were analyzed first with the XRF and then sent off to a lab for ICP analysis. So what is XRF? It stands for Field Portable X-ray Fluorescence, which works by analyzing the elemental composition of certain materials, in this case lead. The XRF radiates the sample with a high energy primary X-ray that's found inside the XRF in a tube. And then it measures the fluorescent secondary X-rays that are emitted off of the atom from the sample being analyzed. A detector measures the spectrum of energy and quantifies the elements present in that specific sample. Lead itself has a unique fingerprint, you could say, that is identifiable by the XRF when analyzed. And it's a potential source of human radiation, these devices. So they need to be handled with care and never pointed at anybody or anything except for the sample itself. So ICP-AES stands for Inductively Coupled Plasma Atomic Emission Spectrometer, which is a lot, but essentially it's the most popular instrument used in labs to analyze elements. And it's good for almost anything except for halogens and inert gases. And it can be done in less than 2 minutes using this machine. And it works by using a hot plasma to break down the sample into individual atoms. And it then excites those electrons to jump to a higher energy level. And as the electrons fall back to their normal state, they release wavelengths of light, and an optical instrument inside the ICP analyzes it and separates the colors and measures their intensity to identifying samples that are present inside. So the XRF in this study used was a Niton XL309. And it was equipped with a 10 millicurie cadmium 109 source, which is just the source, the X-ray source that's used to activate the electrons. Using the XRF, they sampled soil from 12 different residential homes in 6 different cities and 5 US states. And they used 2 composite samples per city in the table here. Each of these locations were residential that were built after the year 1900 and before 1978, which is around the time when lead was really being put into products in homes. And something to note also that they didn't mention here was that was how many samples they actually took before they chose these specific sites. They took a lot more, but they chose these ones, and they did it obviously to include quantifiable samples in the report. But I do think they could have mentioned a little bit more on how they came out selecting these sites. So there's 2 general steps of analysis of soil samples: the XRF process and the ICP-AES process. When sampling lead, there's some guidelines that lead inspectors, risk assessors need to follow. And these are HUD and ASTM guidelines. HUD stands for the Department of Housing, Urban Development, and ASTM is the American Society for Testing and Materials. And in order to follow these standards, a minimum of 2 composite samples needed to be taken from each of the drip line areas. And the drip line is where the roof ends on a house, water falls off, and it's about 2 feet from the house. So samples were taken in the general drip line area. Each composite sample was composed of 5.5-inch cores. And I've got a picture on the next slide of what those cores look like. But they took 5 and they're spaced 2 feet evenly apart to follow the HUD guidelines. And then this was done 2 times to follow the ASTM standards. For the ASTM, they would take 3 samples with the same cores spaced 1 foot apart. And these composite samples were then weighed to about 75 grams. They were pulverized and then either dried by air or by a 700-watt microwave. And they were placed inside a 3-inch stacked sieve, which was composed of 2 layers. First layer would be 2 millimeters, and the second layer would be 250 microns. And they'd shake it up pretty vigorously for 2 minutes until the soil was sieved down to 250 microns. Then they would take that soil, place it in the XRF analyzing cup, and analyze it with the XRF for 30 seconds. And then those samples, the ones that were dried and sieved, would be sent to a National Lead Laboratory Accredited Program, or an NLAP, and those would be analyzed using the ICP at the lab. Here's some graphics. Couldn't find a very good drip line graphic, so just ignore this. But drip line comes right here, falls down about this general area, just 2 feet from the house. And in the guideline, it says to space the samples at least 2 feet away from the house. They'd be taken in this area. These are the cores that they would use to take the soil samples. And right here, I made this, but if you imagine this as the drip line, they would take, for the HUD guidelines, they'd take 5 samples spaced 2 feet apart. And then for ASTM, they would take 3, but they'd be 6 foot apart. Then they'd combine those to be a composite sample. This table right here shows the results for mean XRF and mean ICP analysis, as well as the number of composite samples taken per site. There were 12 of them. And since this research article performed a method comparison and field validation study, the statistical analyses used were a paired t-test, sign test, and a will sign test. And 11 of the 12 sites showed no statistical difference between the mean XRF and mean ICP results for soil lead. But the VA1 was the only one that wasn't included because it didn't pass the equivalency for the will toxin test. Here's the 2 regression lines that the authors performed. They show an almost 1-to-1 correspondence between mean XRF and mean ICP results. The first one was following the HUD guidelines with a slope of 1.02, and the second one following the ASTM guidelines with a slope of 1.06. What does this mean? There's a clear statistical equivalence between mean soil lead values of paired samples collected following the HUD guidelines and the ASTM guidelines. They're samples that were sieved to less than 250 microns and then sent for field and laboratory analysis. The data here was quite extensive with 72 total composite samples across the 12 sites. And there were just a few flaws that I found with that, but I can talk about that in the next couple slides. But the soil types mentioned ranged from dry loamy to sandy. So they did get a good variety of different types of soils that were analyzed in this. There were some strengths and some limitations. Being cost efficient, I think, kind of comprises both of them, depending on what angle you're coming from. If you've already got an XRF and you look at it as you're saving money on laboratory costs and fees, then it's positive. It is a strength. Performing this type of XRF analysis can also be done in less than 2 hours for the sampler, compared to certain labs. You know, you got to send it off to the lab. Sometimes it takes up to 3 to 5 days to turn around. And as a lead inspector myself, I have experienced that where it's taken up to a week. And it's not very fun when the client you're working for needs results the next day. So in that case, an XRF would be very nice to have available. The US method used was the US EPA method 6200, and it is approved for screening for lead. And the specific one that was used in this study was the Niton XL, and it doesn't require a correction factor, unlike some of the older models of XRFs, which makes it a lot easier for the inspector to collect measurements and values. On the flip side of being cost effective, XRFs are very expensive. They can range from $15,000 to $150,000 per instrument. So yeah, and it depends on quality, ability, how new or old the make of the model is. Most companies that I've seen use older models because nobody wants to drop that much money on a expensive XRF. But for comparison, the one used here was released in 1996, and this study was done in the 2000s. The other limitation I found, it might not be a limitation, but was the site location for samples. They were taken in New York, 2 in North Carolina, Virginia, Tennessee, Minnesota. Minnesota's not so East Coast, but the rest of them are early East Coast states. And that being said, they did use a lot of different types of soils when analyzed. And the study wasn't really focused on location. So I'm not sure if it really makes a difference on where the samples were taken, but there wasn't any representation of West Coast or like mid-US. And that's just something that I saw and noted, but I would like to hear your guys' opinions. If you guys saw any other limitations that I might have missed, or strengths, but that's all that I've
Quick question, why do you take the samples along the drip line if you were talking about like how the paint's like flaking off the house? So why wouldn't you just take it next to the house?
Yeah, that's a good question. It's outlined in the HUD and ASTM guidelines and standards, like samples need to be taken along the drip line. Probably more so to take them closer to the house rather than further away, because if you don't know those guidelines, then you might take them even further away from the house. I'm not entirely sure, but since lead paint on the exterior of houses, it falls off. You can imagine people walk around to the house, you know, it gets mixed in with wind, kind of blows, you know. So that's just part of the guidelines rules for sampling, but it's a good question.
Just want to make a comment on the statistical test that's performed. They mentioned a lot of tests for paired samples at each site, and each site has, some sites has only 4 samples. So for people who has taken biostat 1 class, with 4 sample size, it will be really, really hard to see something statistically significant difference.
Yeah.
Okay, so it seems that those tests are pretty useless.
Yeah. I think I failed to mention it earlier, but it was a minimum of 4 composite samples, and each composite sample, you know, is 5 of the core samples combined, or 3 of the core samples combined. And that's also what I was talking about earlier, where it would have been nice for them to mention how they came to including just those 12 sites, because I'm sure, and they did mention that they tested out other sites as well, but they only included the locations that gave enough results for lead, because some of the areas that they tested didn't show any lead. Not sure if it was because lead wasn't used in the paint of that house or not, but they only used samples that included lead. So that could be a possible limitation as well. But yeah, 4 for 1 site is.
And these lead levels, are they pretty dangerous?
What?
Are these very dangerous levels of lead presence in the
Let's
soil?
go back. They didn't really talk about yeah, they didn't talk about the certain levels of lead. It's measured in milligrams of lead per kilogram. And I'm pretty new to lead sampling as well, but I'm not entirely sure how dangerous they are. You can see North Carolina had some of the highest levels, and the rest were a little bit lower. Minnesota had some higher levels as well, but comparatively, I don't know how much,
How bad it
how
is.
bad.
It's a very short article, which I think you probably liked, but one question I had about it was they didn't talk about like practical implications. They basically, they claimed that the FPXRF technology is an improvement and maybe, and their data kind of shows that, but I guess do you know, is there any practical benefit for, using one or the other in terms of cost, in terms of speed with which you get the results, anything of that nature that, because I didn't see much of that, but maybe you saw something or maybe you know something.
I think they were more focused, like we know that XRFs are good tools to use in the field.
Yeah.
It'll obviously save you costs on laboratory analysis, but that is kind of it depends on the company, I suppose.
Yeah.
How often they're sampling for lead. If they do it all the time, then maybe it's cost efficient to get one.
Yeah.
And eventually over time you do enough sampling jobs that it pays for itself and then starts to make money. But I think they're just trying to prove that the XRF is just as good as normal laboratory analysis. So you can do it on your own, save yourself some time, save the week or so that it might take to get results back.
Yeah.
When they sampled in different states, cause you mentioned how like paint used to have lead in it and they're definitely trying to go away from it. Do you know if they try to do any control to be like, okay, let's try to sample houses in the same like range of time when they were made? Or if not, like, do you think they should have, and how should they have gone about that?
Yeah, they back here it shows the years that the houses were built for each site location, and a lot of them were early 1900s. Most of them, I think, the latest was 1947, and lead was, they stopped putting lead in paint in 1978. So I'm not sure when they started. That's a good question. But in between the early 1900s and 1978 was about when they would put it in there. But yeah.
Kind of with the whole East Coast thing, my first thought would be there's probably just greater amounts of highly like high density areas over there because I mean, other than like Salt Lake in Utah, there's not really a lot of 100-year-old homes, so it's potentially like a population over time issue as well.
With more history.
So the goal of these sort of inspections, is it really fixated on finding lead in the paint or structure of the house, or is it more fixated on the absolute level of lead, right? Because I know there are some ways to test like the paint directly. So like when would you use this process as opposed to testing the materials directly?
So usually when people are looking to like renovate or construct a home, these rules apply when there's children around. Yeah. Sometimes it's a new family moving in that wants to, get rid of the house or rebuild it, reconstruct it in some way. The law states that you have to sample for it. If it's there, it needs to be abated. In case there's children around, and I think it's in like the previous 6 months, or the next 6 months. I could be wrong with that though. But abatement, yeah, it applies when there's renovation. Did that answer your question?
Yeah, more or less.
Any thoughts?
Anyone else? Going, gone. All right.